welcome back. In this lesson, we're going to look at linear functions and applications. So what is a linear function? It's a relationship we'll call it f for function, defined by y, which is also known as f of x. From the last lesson was the slope-intercept form of the equation of a line. So real numbers. An example could be if you had like y equals 5 minus 3x, which you can also write as f of x equals 5 minus 3x. So this is a linear function. I can see that my b value is 5, so that's my y-intercept, and my slope is negative 3. That's my m. We have specific notation we use for functions. Generally, we use the letters F, G, H. Really, you could use any letter you want, and they are used to name functions. So for example, in the last linear function I wrote, the name of the function would be f, because it's f of x equals 5 minus 3x. But you can use any function, any letter that you like. And it is a function of x, since x is the variable that I'm using. If I was to maybe talk about time being the independent variable, I might want to replace x with t, in which case this would need to turn into a t. One of the things that you'll be required to do is evaluate functions, and that's simply just you're going to be substituting the values for x into the expression here. So here the function is g of x equals negative 4x plus 5. If I'm asked to find g of 3 rather, all I need to do here is replace the x with the 3. So I'm going to have negative 4 times 3 plus 5, and that would give me negative 7. And I could also express that as an ordered pair. When x is 3, g of x is another name for y, right? And it produced negative 7 for my y value. So that could be expressed as 3 comma negative 7. Okay, I'll leave all of you to try g of b on your own. Let's talk about supply and demand. So this is a business application, right? And we are in business calculus, so we'll see applications where we're looking at business. And supply, demand, law of demand and law of supply are things that you may have heard of before, but if not, let's define some of these words. So supply is just the quantity of a certain good. Okay, so it could be like apples, bananas, iPhone watches, or iPhones, anything that they're selling, okay, that producers are willing to provide. Demand is the quantity of the good the consumers are willing to buy. So to summarize, supply has to do with the producers and what they're willing to provide. Demand has to do with the consumers and what they're willing to buy. So what is the law of demand? Generally, it just says as the cost of something increases, the demand is going to decrease, right? So the more expensive things become, the less and less consumers are willing to pay that price. So as the price of an item increases, consumers are less likely to buy an increasingly expensive item. So the demand of the item will decrease. The law of supply, on the other hand, still talks about cost increasing, but at this time, as cost increases, the supply will also increase. So, basically the law of supply just says as the price of an item increases, producers are more likely to see a profit in selling the item. So that's why the supply of the item would increase, right? Because the business would want a profit. At this point, you want to feel free to pause the video to read the problem, and then you can unpause it and we'll work it out together. Suppose that Jim, manager of public supermarket, has studied the supply and demand for watermelons. He has noticed that the demand increases as the price decreases. He has determined that the quantity in thousands demanded weekly, Q, and the price in dollars per watermelon, P, are related by the linear function P equals D of Q, which equals 9 minus 0.75 Q. So again, I know this is a linear function. It's in the form of f of x equals mx plus b. Find the quantity demanded at a price of $5.25 per watermelon. So here's my price, which is P. I know that's my Y. And I'm going to substitute 5.25 for P and then set that equal to 9 minus 0.75 Q. And I want to find the quantity demanded, right, which is Q. So I'm going to solve for Q. So I'm going to subtract 9. And I would get negative 3.75 equals negative 0.75 Q. And then, of course, I'm going to divide both sides by negative 0.75. And I would get 5 equals Q, right? And remember that that's in the thousands. So basically what that tells me then is at the price of $5.25 per watermelon, the quantity demanded is going to be 5,000 watermelons. Jim also noticed the quantity of watermelon supplied decreased as the price decreased. Price P and supply Q are related by the linear function P equals S of Q equals 0.75 Q. Find the quantity supplied at a price of $5.25 per watermelon. So again, here's P, and our supply equation is P equals 0.75 Q. So I'm just going to replace P with 5.25 and set it equal to 0.75 Q, and you're going to divide both sides by 0.75, and you end up with 7 equals Q. Again, that's in the thousands. So that's just telling me that the quantity supplied is 7,000 watermelons. Okay, let's graph both of the functions and see what happens here. So we know that for that first function, okay, we'll call it, from question A, that was P equals 9 minus 0.75 Q. We know that one of our ordered pairs was 5 and 5.25, right? So we need at least 2 points to graph that. We know, of course, it's going to come out to a line because it's a linear function. So let's say I make this time the price 3.75, and I'm going to set it equal to 9 minus 0.75 Q. And then I'm going to eventually find that Q equals 7. So now I have these 2 points I can use to graph it. I've got 7, which is Q. Q is, it's basically your X. And then the point that we found in letter A, right, was 5, comma 5.25. So I can graph that. That's my demand equation, right? So 7 and then 3.75 is going to go maybe like right about there. And then you've got 5 and 5.25, which is maybe going to go right about there. Okay, and it's going to look something like that. Okay, so there's your demand equation. And then for part B, that was our supply equation. We already know that we can use 7 comma 5.25, but let's find another point. Let's just make Q equal to, or P rather, equal to 3. So we get a nice number, and we get 4. So that means that I have the point 43. And then from letter B, it was 7 comma 5.25. So 43 is going to be right there. And then 7 and 5.25 is going to go maybe right about there. Okay, and we'll just plot the points. Okay, here's your supply equation. And of course we have price down here and quantity here. Okay, and notice that point right there. So that has significance. Okay, the point that the two lines intersected is called the equilibrium point. And when we say equilibrium, that's when the supply equals the demand. And basically also the economy, in terms of the economy, it's said to be at equilibrium. Okay, I also want to point out the term equilibrium price, which you can imagine is just the price found at the point of intersection. And then, of course, the equilibrium quantity would just be the quantity found at the point of intersection. What I'd like you to do now is pause the video and use algebra to find the equilibrium quantity and price for the watermelons in the previous example. And then you can unpause the video when you're ready to move on. So for those of you that just attempted that problem, you're going to take the demand equation and then the supply equation and set them equal to each other. And then you're going to just solve for Q. And then once you find Q, you're going to take that value and you can choose either to plug it into the demand equation or the supply equation to end up with your equilibrium quantity and price. So you should end up, when you solve this, with Q equal to 6. And then, like I said, you're going to take that 6 and plug it in. I'm just going to plug it into my demand equation. So I'm basically finding where Q is 6. So you would just do 9.9 minus 0.75 times Q, which is 6 here, and you end up with 4.5. So what that tells me is, again, the Q is in thousands. So the equilibrium quantity would be 6,000 watermelons, and the equilibrium price would be $4.50, which also tells me that there's no shortage or surplus. It's just the right amount. Let's look at a cost analysis problem, which is another type of business application. So we will see this term fixed cost, which, if we were to define it, is just the cost for designing the product setting up a factory, training workers, etc. So anything that, basically adds cost to your business. So what is special is about fixed cost is if you add it to the cost per item that you're producing, it's going to equal the cost of manufacturing that item. So you're taking into account everything that is involved with making this product, plus how much it costs to create the product, and that's going to equal the cost of manufacturing that item. So what's important to remember here is that fixed cost equals, or rather, I'll give you this equation instead. Fixed costs plus cost per item equals the cost of manufacturing the item. Okay, let's see how we can apply this. You might want to pause the video and read the example. A small company decides to produce video games. The owners find that the fixed cost for creating the game is $5,000. So that would be, how much it costs maybe to go to someone to design this game for you, plus setting up a space for designing this game and manufacturing the game, plus training the workers who will be manufacturing this game, right, etc. So they find that the fixed cost for creating the game is $5,000, after which they spend $12 to produce each individual copy of the game. Find a formula, C of x, for the cost as a linear function of x, the number of games produced. Okay, so I know that I'm going to start out with C of x equals, okay, because it's my cost function. So how can I relate the cost to produce one, item? Well, I know that it's going to cost $5,000, plus I know it's going to be $12 for every individual copy. I don't know how many copies there will be. I know that those copies are going to be X, right? That X stands for the number of games produced. Every game produced is $12, so it's going to be plus 12X. So how would I interpret something like this? Well, the slope, which is 12, right, helps me interpret this. And what that's telling me is, so my slope is 12, right, which we can write 12 over 1, which, remember, slope is change in y over change in x. So what this is telling me is, okay, y is my cost, and x is a game. So this is telling me that for the cost to produce each additional game is an additional $12 on average, right? So the cost to produce one additional game is an additional $12. And I'm going to say on average because it may not always be exactly 12, but it can be close to it. If we're dealing with a linear function, then it will pretty much stay constant and not change. But theoretically, it's on average. We also have this term called marginal cost, and then, of course, a linear cost function. So two important terms here. So marginal cost is the rate of change of cost, right? Cost is C of x at a level of production x and is equal to the slope of the cost function at x. And it's also important to note that marginal cost approximates the cost of producing one additional item. So, that $12 there is the marginal cost. And a linear cost function says that in a cost function of the form c of x equals mx plus b, which is what the form was for the cost function in our previous example. Conversely, if the fixed cost of producing an item is b, which remember is your y-intercept, and the marginal cost is m, then the linear cost function c of x for producing x items is c of x equals mx plus b. Okay, so in my previous example, we know that the fixed cost was $5,000, and we know that the marginal cost is $12, right? That tells me that I can write that expression as a linear cost function. Let's practice finding marginal cost and also finding cost functions here. So the marginal cost to make X batches of a prescription medication is $10 per batch, while the cost to produce 100 batches is $1,500. Find the cost function c of x given that it's linear. Okay, so right there, that gives me permission to write c of x equals mx plus b. Now, it tells me that the marginal cost is $10 per batch. Okay, so I know that that's what the marginal cost is. They give me this other clue. It says, while the cost to produce 100 batches is $1,500. Well, I know that X is the number of batches. So I know that X equals 100. And that would mean that C of X would have to be 1,500. That's my cost function. So I can use my point slope formula because I have a point and a slope, right? I've got my slope, and then I have a point right here. So I'm going to have, if you remember, the point slope formula goes y minus y1 equals m times x minus x1. So y is just c of x. y1 would be 1,500. I know m is my marginal cost, which is 10, times x just stays x minus x1, which is 100. And then I'm just going to distribute through and move some things around, and you end up getting c of x equals 10x plus 500. So there's my cost function. I'll have you all try the next problem on your own. and then you can unpause when you're ready. Now we're going to go over break-even analysis. So let P be the price per unit and let X be the number of units sold, okay, which is demand, right? Here's some important terms to kind of be familiar with. So you'll hear the word revenue, profit, break-even quantity, break-even point. What's the difference? So revenue is just the amount of money that a company receives. Okay, so R of X is just going to equal P, which is the price per unit, times the number of units sold. So I know that R of X equals P times X. Okay, that's going to give the amount of money that the company would receive. The profit is the amount of money a company makes after paying its costs. Okay, so how would I write an equation for that? Well, P of X, which is my profit, how would I find the amount of money that the company makes after paying its costs? Well, I would need to take the revenue and I would subtract the cost, and that's going to leave me with the profit. So if I take the amount of money that a company receives, subtract the cost for producing that product or manufacturing it, it leaves me with the leftover, which would be your profit. Break-even point, break-even quantity, break-even point, those are things we talked about when we looked at equilibrium quantity and equilibrium point. So here we're just dealing with the break-even analysis. The break-even quantity is just the number of units, X, at which revenue equals cost. So the amount of money that you put into manufacturing that product is the same amount of money that the company receives. So here in equation form, it's just telling me R of X equals C of X. Okay, which also tells you that there is no profit, right? So P of X would just equal 0. And then the break-even point is just the ordered pair. So it's the corresponding ordered pair. So it's like the break-even point or the equilibrium point. And it indicates the point of 0 loss or profit. Okay, you can pause the video and then we'll work this out together. A firm producing poultry feed finds that the total cost, C of X, in dollars of producing and selling X units is given by C of X equals 20X plus 100. Management plans to charge $24 per unit for the feed. Determine the revenue function. Okay, well, I know here the price is given to me. It's 24, right? And how do I find revenue? It's price times number of units sold. So the price is 24 times X. I don't know what X is. Okay, they don't tell me the number of units. So that's my revenue function. Very easy. How many units must be sold for the firm to break even? So here I'm trying to find X, and I want to find where it breaks even, so where the revenue equals the cost of producing that item. So I know that R of X is 24X. I'm just going to substitute that in. And I know C of X, because it was given to me in the problem, it's 20X plus 100. So again, I'm just going to replace, and then I'm going to solve for X. So I'm going to subtract 20X from both sides. You get 4X equals 100. And then X would equal 25. So what that tells me is that the company, if the company was to sell more than 25 units, the company makes a profit. If it sells fewer than 25 units, it's going to lose money, right? So 25 is where they break even. What is the profit if 100 units of feed are sold? Okay, so how do I find profit again? It's after you take the cost and subtract it from the revenue. So again, I know R of X is 24X and C of X is 20X plus 100. We want to make sure we put the 20X plus 100 in parentheses because you're subtracting that entire quantity. And then we're going to distribute the negative and combine our like terms. So this is my profit equation. And now I'm going to substitute in 100 for X. And I would get $300 is my profit. How many units must be sold to produce a profit of $900? Okay, so let's say you're in this business and you're like, I want to make a profit of $900. How many units would I need to sell? Well, again, I know from the last problem, P of X is 4X minus 100. And this time I'm given P of X. So I'm just going to substitute 900 in. And then of course solve for X. So add 100 to both sides, divide by 4. You end up with 250 equals X. So if you want to make a profit of $900 from this specific product, you need to sell 250 items. And that's the end of this video on linear functions. In the next video, we'll look at properties of functions. Have a great day, everyone.